Right, today in Algebra 2, we're going to start section 5.2, which is properties of exponents and radicals. Our essential question for this section: how can properties of exponents and radicals be used to rewrite radical expressions? After this lesson, you should be able to use properties of exponents and radicals to simplify radical expressions. We're going to look at the properties of rational exponents. We're going to let m and n represent rational numbers. Remember, rational means that the decimal either terminates or repeats a pattern. And we're going to let a, b represent our numbers, and b cannot equal 0. This table should look very familiar to you. We have looked at the properties of rational exponents. We reviewed these a while back, so let's just go over them quickly. The first one, the product of powers, just as if I have the same base, then I add my exponents. So an example of that, only this time using rational exponents, would be like, let's say 4 to the 2/3 power times 4 to the negative 1/3 power. It's going to equal, I have the same base, my base stays the same, I add my exponents. 2/3 plus negative 1/3 is 1/3, so 4 to the 1/3 power. Power of a power, so this means if I have an exponent and I'm raising it to another exponent, I multiply my exponents. So let's say I have 7 cubed, all of that to the 2/3 power. I multiply 3 times 2/3 and I get 7 squared, which would actually just give me 49. Power of a product, so if I have two things being multiplied together, raised to an exponent, I can raise them both to an exponent instead of multiplying them together first. And so let's say I have 16x, all of that to the 1/2 power. This would be the same thing as 16 to the 1/2 times x to the 1/2. I can simplify that because 16 to the 1/2 power, that means the square root of 16, which is 4. And then x to the 1/2 power means the square root of x. So I could really write that as 4 square roots of x. Negative exponent. So remember that the negative exponents, we cannot have them, so we just move them. So if I had 5 to the negative 2 power, that would really be 1 over 5 squared, which would really be 1 over 25. A zero exponent, anything raised to the 0 power is equal to 1. So 810 to the 0 power equals 1. Quotient of powers. So if I have two things that have the same base being divided, I subtract my exponents. So let's say I had 3 to the 4th divided by 3 squared. So they both have a base of 3, so I know it's going to be 3. 4 minus 2 is 2. 3 squared, 9. And finally, the power of a quotient. So I can just raise them to the power before I divide. So here we'll do like x over 16 to the 1/2 power. The same thing as x to the 1/2 over 16 to the 1/2. X to the 1/2 I know is the square root of x. 16 to the 1/2 is 4. Okay, so we're going to use these properties of exponents. It first asks us to rewrite each expression using the properties of exponents. Okay? 81 to the 5/6 power times 81 to the negative 1/3. So I notice that they have the same base, so I want to add my exponents. Okay, right? So this is going to be 81 to the 5/6 plus negative 1/3. So 5 over 6 plus negative 1 over 3. I need a common denominator. My common denominator is going to be 6. So I'll multiply this by 2. So really, I have 81 to the 5/6 power minus the 2/6 power, which is 81 to the 3/6. The 3/6 will reduce, right, to 1/2. So this is really 81 to the 1/2 power. 81 to the 1/2 power is the same thing as saying the square root of 81. We know that the square root of 81 is, in fact, 9. So when we rewrite that using the properties of exponents, we end up with 9. Let's look at number 2. I have xy to the 3rd power divided by x to the 1/3 power, all of that to the 2/3. Very first thing I'm going to do is on the inside, right, I have an x and an x. They're being divided, so I subtract my exponents. So really I have x to the first minus 1/3. So 1 minus 1/3 is x to the 2/3. So this is really x to the 2/3 y cubed, all of that to the 2/3. When I go ahead and subtract this 1 and this 1/3 together. So now I want to raise all of that to the 2/3 power. So I multiply 2/3 by 2/3. So 2/3 times 2/3 gets me x to the 4/9. Multiply 3 times 2/3 and I get y squared. So now y squared stays y squared, x to the 4/9. So I can rewrite this as y squared. The 9, that is my root. So 9th root of, I can either do x to the 4th like that, or I could say y squared 9th root of x to the 4th. Remember, these are the exact same thing. All right, number 3. 3 divided by 32 to the 2/5, all of that to the 1/2. 3 and 32 are not the same base, so I'm just going to raise them each to the 1/2. So I get 3 to the 1/2 over 32 to the 2/5 to the 1/2. So I multiply. So 2/5 times 1/2 becomes 1/5. So here, 3 to the 1/2 power, that's the square root of 3. This is the 5th root of 32. The 5th root of 32, though, I know what that is. That's 2. So this is the square root of 3 over 2. All right, the last one. I want to do what's in parentheses first. I'm going to raise each of these to the 2/3 power. So I have 2a to the 1/3, a to the 2/3, b to the 1/2 times 2/3 becomes 1/3. Now I have these two a's, right? Same base, so I add my exponents. So it's 1/3 plus 2/3 is 3/3. Well, 3/3 is just 1, so I just have 2a to the first power, b to the 1/3 power. I can make that 2a cubed root of b. All right, let's move on. Extend the properties of exponents to derive properties of radicals. The reduced radical form of an expression has all nth roots or perfect nth powers in the radicand simplified, and no radicals remain in the denominator. Okay, so we're going to rewrite using the properties of exponents. So here I have the nth root of a times b. I can separate that. That's just saying the same thing. Okay, so it says no radicals remain in the denominator. We want nth powers in the radicand simplified. So the only way that I could change this is this would be the nth power root of a times the nth root of b. Okay. Number 2, the cubed root of 16x to the 5th. Okay. Well, 16, I can do factor tree on this, right? 16 came from 8 and 2. 8 came from 4 and 2, 4, 2, and 2. It's a cube root, so I need 3 to be alike. That one stays behind. Okay? So I've got a 2 that comes out, and I know I'm going to have a cube root of 2 left. X to the 5th. Okay? So I can either turn this into, okay, there's 2 different ways I can do this. So I can make x to the 5th x cubed, right, since this is a 3, and then 3 plus 2 got me 5. Or I could divide. How many times will 3 go into 5? It goes in once, so I know that I have 1 that comes out, and then what's left behind, 2. So I have 2x that comes out, cubed root, this 2 stayed behind, and an x squared stayed behind as well. Number 3. The 4th root of 81, okay, we don't know that. Then again, factor tree, 9 and 9, 9, 3, 3, 3, 3. This time I need 4 to be alike. I have 4 3s, okay? So I know I have a 3 that comes out. A to the 8th. 8 divided by 4 is 2, so I have an a squared that comes out. B to the 5th. 5 divided by 4 okay, is 1, right? So I have a b that comes out, but then there's 1 left over, so then I have the 4th root of b to the first power, or just b left behind. Number 4, I need to separate this first. So first thing on number 4, I need to make this say the cubed root of x to the 4th y squared. And actually, you know what? It's not before we even separate that. So let me erase this. You see that I have an x on top and an x on the bottom. I'm going to go ahead and combine those. So x to the 4th on top, x on the bottom. Really, I have an x cubed on the top. So I have the cubed root of x cubed y squared over the cubed root of 125. Okay? So I'm just going to work it separately. So on top, the cubed root of x cubed, well, that's just x. Cubed root of y squared, well, this exponent is smaller than my index, so nothing's going to come out. So that's cubed root of y squared on top. Over on the bottom, the cubed root of 125. Hopefully we know that one by now. It's 5. So there's our answer. X times the cubed root of y squared all over 5. Now we're going to look at the product property of radicals. Okay. We've been doing this. It's what we just said. The nth root of a, b. I can separate that, make it nth root of a times the nth root of b. I could change it to exponents. Quotient property. Again, that's just what we were doing. I can separate them. So we're going to rewrite the product or quotient of a radical. We're going to put it in reduced radical form. Okay? So I have the 5th root of 16 times the 5th root of 8. Multiply 16 and 8 together. And when I do that, I get the 5th root of 128. Do factor tree. Well, I know this came from 16 and 8. 16, 4 and 4, 4, 2 and 2, 2 and 2. 8, 2 and 4, 4, 2 and 2. I need 5 to be alike to come out. So 1, 2, 3, 4. I have 5 2s right here. And those 2 got left behind. So this comes out as a 2, 5th root of 2 times 2, 4. There's our simplified radical form. Number 2, the 6th root of 8x times the cubed root of 2x. I cannot go ahead and multiply these together because they don't both have the same index. One's a 6 and one's a 3, so I need to change them to exponents and make this 8x to the 1/6 power times 2x to the 1/3 power. So now I have 8 to the 1/6 power. I can just go ahead and 8 to the 1/6, x to the 1/6, 2 to the 1/3, x to the 1/3. My x's, I have the same bases there. So I could go ahead and combine my x's. So let's say I've got 8 to the 1/6, 2 to the 1/3. I have x to the 1/6 and x to the 1/3, so I need to add 1/6 plus 1/3, common denominator of 6. So it's really x to the 3/6, which is 1/2. I'll leave it to the 3/6 for now and see if I want it to be at the 1/2 later. All right, so now I have 8 to the 1/6 times 2 to the 1/3. There's several different ways that I can work this. Okay. The easiest is going to be make them have the same base, right? I have an 8 and I have a 2. I can easily turn an 8, okay, into a base of 2 because I know that 2 cubed is 8. So when I rewrite this, instead of 8, I'm going to say that's 2 cubed, and that's to the 1/6 power, right? So really, that is 2 to the 3/6 power. So 8 to the 1/6 is the same thing as saying 2 to the 3/6 times 2 to the 1/3 x to the 3/6. Now that I have the same bases, I can add my exponents. So I get 2 to the 3/6 plus 1/3. Again, I need a common denominator. So I get 2 to the 5/6 x to the 3/6. So this is the 6th root, right? They both have a denominator of 6. So this is the 6th root 2 to the 5th, 2 to the 5th is 32, x cubed. There we go. Number 3, I have the cube root of 2n over the 9m. So very first thing I want to do is separate this, make it the cube root of 2n, all of that over the cube root of 9m. Okay, we cannot have a radical of any kind in the denominator. So here I have a cubed root, so I need to create a perfect cube in the denominator. So the cube root of 9, that's not a nice whole number, okay? But I know that the cube root of 27 is a nice whole number. So what do I have to multiply 9 by to get 27? 3. So if I'm going to multiply by the cube root of 3, then I also have to turn this m into a perfect cube. Right now it's an m. I need it to be an m cubed, so m squared. That's what I want to multiply by. Again, whatever I multiply the bottom by, I have to multiply the top by. So I'm also going to multiply the top by the cube root of 3m squared. So on top, I get the cubed root. 2 times 3 is 6, m squared n. Over, on the bottom, I have the cubed root. 9 times 3 is 27, m times m squared, m cubed. Okay. So the top, cube root of 6, I can't do anything with that. The cube root of m squared or n, I can't do anything. So the top is saying the cube root of 6m squared n over, on the bottom, the cube root of 27 is 3. The cube root of m cubed is 3. So there's our answer. Okay. So let's look at number 4. The 5th root of 7 divided by 16x cubed. So this is really the 5th root of 7 over the 5th root. Sorry. Okay, so 5th root of 7 over 5th root of 16x cubed. Now I have a 5th root on the bottom. I need to make a perfect 5th root. Okay, so 5th root of 16, that's not a nice whole number. So what do I know is a nice 5th root? 32. What do I have to multiply 16 by to get 32? 2. X cubed, I need to be an x to the 5th, so I need 2 more, so I need an x squared. So I'm multiplying top and bottom by the 5th root of 2x squared. So on top, I get the 5th root, 7 times 2, 14x squared. Over the bottom, the 5th root, 16 times 2, 32, x cubed times x squared, x to the 5th. That equals, on top, the 5th root of 14x squared stays. Over the 5th root of 32 is 2, the 5th root of x to the 5th is x. There's our answer. Okay. All right, let's get in multiplying binomial radical expressions in today as well. First, I guess we'll go on to number 5 here. Sorry. Looking at the wrong page of notes. Okay, so number 5. 4 times this, the 4th root of 27x squared times the square root of 3x. Again, I'm going to take each of these out. So I'm going to make this say the 27 to the 1/4 because they don't have the same indexes, so I can't do anything with them right now. X to the 2/4, 3 to the 1/2, x to the 1/2. I have a 27 and a 3. They're not the same base, so I asked myself, can I make 27 have a base of 3? Sure I can, right? Because 3 cubed is 27. So I'm going to rewrite 27 as 3 cubed, and then it's still to the 1/4 power. Then I've got x to the 2/4 power. 3 to the 1/2, x to the 1/2. So now I can go ahead and do these bases, keep at a base of 3, add my exponents. So I have 3/4 plus 1/2, right? So 3/4 plus 1/2 gives me 3 to the 5/4. X to the 2/4 plus 1/2, so 2/4 plus 1/2 is x to the 4/4. If I take the 4th root, I can rewrite this, okay? 3 to the 5/4, that's the 4th root of 32, or sorry, 3 to the 5th. And then x to the 4/4 is really just an x, so then I have an x on the outside. So this will simplify x to the 4th root of, well, what is 3 to the 5th? 3 to the 5th is 243. So then let's see, can I do factor tree on that? Yes. So 243 is 3 times 81. 81, 9, and 9. 9 breaks down to 3 and 3, 3 and 3. I need 4 to be alike. I have those 4 3s are alike. This one stays behind. So this simplifies to 3x on the outside, 4th root of 3. Okay. All right. All right, for time's sake, we're going to go to the back of these notes real quick. We're going to look at multiplying binomial radical expressions. Okay, so multiply binomial radical expressions, put in reduced radical form. I just want to, sorry about that. I just want to distribute, okay? So I have the cubed root of 7 times 2, so 2 cubed root of 7. Cubed root of 7 times the cubed root of 49, so minus, they both have the cubed root, so I can multiply, so 7 times 49 is 343. Let's see if I can simplify this. So let's do factor tree. I know this was 7 and 49. 49 is 7 and 7. I need 3 of them to be alike. I have 3. So this is really 2 cubed root of 7 minus 7. There's our answer. Number 2, 2x minus the square root of 3 times 2x minus the square root of 3. This is the same thing as saying 2x minus the square root of 3 quantity squared. So I'm going to use my shortcut. Okay, so remember the shortcut says I take the first term, I square it. So 2x, square that whole thing. Multiply these two together and double it. So 2x times negative square roots of 3. Okay, and then doubled, so it gets me minus 4x square roots of 3. And then the last term squared, square root of 3 squared plus 3. So 2x squared, 4x squared, minus 4x square roots of 3 plus 3. There's our shortcut. Number 3, x minus the square root of 10 times x plus the square root of 10. These are conjugates. So I'm going to use the conjugate shortcut. Right. The conjugate shortcut says the very first term squared, so x squared. Always minus the last term squared. Square root of 10 squared, 10. So x squared minus 10. Number 4, the square root of 6 times 5 plus the square root of 3, distribute. So I get 5 square roots of 6 plus the square root of 6 times the square root of 3. I can multiply those because they are both have the same index, so 6 times 3 is 18. Do factor tree, 18 is 9 and 2, 9, 3, and 3. It's a square root, so I need 2 to be the same. So this is 5 square roots of 6 plus 3 square roots of 2. All right, that's where we're going to stop for today, day 1 of 5.2. Your homework will be the Envision 5.2 worksheet, numbers 19 through 36 and 41 through 44. Remember, we will be taking quiz 5.1 tomorrow, and then we will finish up section 5.2 tomorrow. All right?